It's not the biggest boat on the water, and it's certainly not the most refined, but it makes 680 horsepower, goes almost 80 miles per hour, and puts big grins on our faces when we get behind the wheel. Today on Engine Power, the Lake Missile takes flight.
Today is a day that we have been waiting for a very long time. Our 1974 Glencoe jet boat is now sporting a brand new 688 horse Bullet, and we have been itching to get this chunk of metal flake back out on the lake. And with me is LT. He's playing hooky from Truck Tech. Now, LT, are you an actual boat guy, or?
Well, you know what? I actually grew up on the coast of Maine. I have spent a lot of time in a lobster boat. It's a little bit different than this. This one might be a little bit quicker, but I'm excited.
This is not actually a lobster boat, but very close. But I'm glad you're along because I'm a bit of an aquaphobe, which I'm a landlubber. And you know, the whole thing with that is I'd rather be on land and have something like this on a dyno. But there's no way I'd miss a chance to drop the hammer on this on the lake.
Well, you know what? I think you have nothing to worry about. We're in good hands. I do have one question for you, though.
Okay.
How in the world did you get such a big valve cover on this LS?
This is not an LS, but I appreciate your attempt at levity.
No, I'm just kidding. I can tell a big block forward a mile away.
Oh, God. The weirdest thing is there's no brakes on this thing.
What'd you say? You want me back up fast and hit the brakes?
Just don't kill me, Clark.
Can't see the edge of the trailer.
There's no turning back now.
This is it. All right.
Whether it's in the water or on the asphalt, a big block Chevy does one thing: make whatever it's attached to go really fast.
Oh yeah! Hang on!
Hang on, hang on!
Here we go!
Oh boy! Whoa! Oh! Ouch! 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 This has a totally different feel than a car. To pardon the pun, I'm truly in uncharted waters. It's like riding a horse. You lead it in a certain direction and hope for the best. What's more, the throttle affects the steering as much as the steering wheel does. I find myself looking for the brakes, but of course, there aren't any. I've got to plan my stops well in advance. This thing has a lot of power. I mean, on a couple of those runs, we were a little bit over 75 miles an hour on the GPS.
Keep moving. You know, it makes me a little nervous with how bumpy it is. Like there's no, you know, like
yeah.
no handle or anything to hold on to. But other than that,
yeah, no, that's relatively scary in my book. But you want to drive?
Yes.
Well, no better time like the present. Just remember, don't throw me in the drink. I swim like I swim like an anvil.
No promises.
Okay. Don't hit nothing. This thing steers really hard.
Does the seat adjust?
The seat does not adjust. Remember, this thing has thrust. Okay, there you go.
Just stab and steer, right?
Yeah.
The first thing I noticed about this particular boat is how touchy the throttle is. Normally, most boats use a hand lever, but this one has a foot pedal just like any hot rod. And if you're not careful when you're bouncing through the wake, you'll give it a little bit more gas than you intended.
Make some circles.
Even though you've really got to put some muscle into the steering wheel, I was impressed with how well this 45-year-old jet boat handled the tight turns. In fact, it kind of defied my expectations.
Just flip the throttle here, slow down.
Tell you what, Pat, that thing's actually pretty fun to turn around. I mean, it'll kind of come up on a curve like that.
Yeah, this thing doesn't turn very well at all. Well, what'd you think?
We didn't die, so.
I'm very thankful for that, actually. So
This thing is a blast, man. I'm really impressed by the response. You just kind of roll into it and you're, poof, you're on plane and you're gone.
Up next, we'll show you how the jet boat turns all that horsepower into thrust in the water.
welcome back to Engine Power. Today we've got our Glencoe jacuzzi drive jet boat out on Old Hickory Lake in Middle Tennessee. This Lake Missile is putting out 329 more horsepower than it did the first time we took it out. We bought this boat from Dwight Brooks, who decided to hang up his captain's hat to spend more time with his grandchildren and work on classic cars. It was in great shape and had a sporty 351 horsepower 454 in the back. We took it out for a quick test run and could tell it had serious potential. We upgraded the big block for another big block Chevy, a complete marine crate engine from Blueprint Engines. We couldn't resist putting it on the dyno just to find out how stout this new power plant was. It pumped out 680 horses and 669 pound-feet of torque. Before we dropped the engine in, we wanted to replace the hoses with all new Earl's lines and fittings. No one wants to be stranded out on the water, and Earl's pieces are built for reliable performance in any situation. With this engine turning higher RPM, an SFI-approved flex plate from Summit provides an extra measure of safety. Once the engine was mounted up, we installed MSD's latest marine ignition box, the 6M3L. It's a simple plug-and-play setup with our MSD distributor and mounts cleanly to a plate we fabbed up out of 18-gauge aluminum. The Glencoe performed admirably to begin with, but you can really feel the difference with the Blueprint engine out back. We call this the Lake Missile, and with the added acceleration and horsepower, it feels like you're powering a rocket headed into orbit.
These things are supposed to throw a rooster tail, and this is all by the trim right here, so let's see if we can get her to throw a big rooster tail.
Yeah, play around with it, see what happens.
We've done plenty of big blocks here in engine power, but this is the first time we've done one for a jet boat.
So we figured we'd show you guys how this boat turns all that horsepower into thrust on the water.
Water is drawn into the jet drive through an intake grate on the bottom of the boat. The impeller is directly coupled with the engine, so if the engine's running, it's turning, pulling in water. As RPMs increase, water is drawn in faster and the impeller forces it into the nozzle at a higher pressure, creating thrust. More engine RPM will create more thrust and push the boat faster.
The reverse gate allows you to control the direction of thrust. With it covering the nozzle, it directs water towards the front of the boat, pushing the boat backwards. With it raised, the boat moves in a forward direction. Steering is controlled by a cable. The nozzle has a swivel point to steer the boat left and right. The driver can also control the trim. This is done via a hydraulic cylinder that is attached to the nozzle. It moves the nozzle up and down to control the bow of the boat during acceleration and cruising.
That's the science behind a jet boat. But once you're on the water with the throttle floored, intellect turns into one emotion: pure primal joy.
This thing is too much fun.
What do they say? Get you some of that?
As long as I don't fall out of it, I'm fine, but man, oh man. This thing basically feels like it's got a really high stall converter in it.
Oh, it's great. And I mean, the thing's running wide open all day long. Temperature's great, oil pressure's great. I mean, what more could you ask for? I mean, it's a little thirsty. We're burning through some fuel.
This is an expensive hobby. So anybody who does this, man, I'm not saying I'm converted, but I'll tell you what, couldn't be a prettier day out. And we got big block horsepower, screaming behind us, big old rooster tail.
You know what would be cool, though?
What?
Stick a Duramax back there.
See, I knew this was going to go there.
Oh, man. Well, we got about half a tank left. What do you say?
I hope we can actually make it back, because we're actually pretty far from where we started, so.
Do you remember how to get home?
No.
That's all right.
So you're navigating, so.
I dropped some breadcrumbs.
Okay. All right, let's head back.
Up next, the Blueprint Chevy Big Block gets a heavy-duty valve train assembly.
Now we're going to turn our attention to our latest engine build, and its foundation is a Blueprint Engine's 632 cubic inch tall deck short block assembly. Now it incorporates some features that aren't available in OEM applications, like provisions for both wet and dry sump oiling, large Siamese cylinder bores, and it has cast-in clearance for stroker applications. From their factory, it's designed to make over 800 horsepower on pump gas. But since this bullet is going into XOR's Willys wagon and will be turning a huge set of mud tires, we need to step up the power to race levels exceeding 1,000 horsepower. The first step was installing a set of Mahle Elite Sportsman Series 42cc domed pistons, bringing the compression ratio up to an impressive 15.03 to 1. The pistons were made into a set of Eagle forged H-beam connecting rods with an upgraded ARP L19 bolt. Comp Cam's solid roller camshaft provides the proper lift and duration for this high performance application. A billet aluminum Jesel belt drive setup keeps the cam timing accurate. Finishing out the front end is an ATI super damper. On the bottom end, a Melling high volume oil pump and a 7-quart oil pan. Eliza and Jeremy came down from the XOR shop and torqued down the AFR 385cc cylinder heads. These flow 452 CFM at 800 thousandths valve lift, and that extra air will help us reach our power goal. Valve train components are critical on an engine of this level, so we chose some heavy-duty parts, starting off with a set of Comp Cam's solid roller lifters. These are from their Elite Sportsman Series, and they're a tie bar style lifter with an 842 body. The unique thing is they have an offset lifter cup on the intake side to help clear that big 385cc port. Before installing the lifters, they are fully lubricated in Royal Purple break-in oil. Make sure they slide freely in the lifter bores. A little high-pressure lube holds the rocker stand shims in place during assembly. The bolts that go through into an intake port are sealed with Permatex thread sealant. The billet steel intake and exhaust rocker stands are different, so make sure they're in the right spot to ensure correct geometry. The stands are torqued to 65 pound-feet. With our rocker stands in place, it's time to sew up the rest of the valve train, and that will start by dropping in some new push rods. We called up Trend Performance, and they sent us a set of heavy-duty push rods for our application. They are 5/16 balls on each end, 135 wall thickness, and their lengths are 8/850 on the intake and 9/900 on the exhaust. Extreme pressure lube is put on both ends of the push rods to prevent wear on initial startup. Finally, the shaft-mounted rocker arms get bolted to the stands. This is a complete Jesel Sportsman Series system designed specifically for our AFR head. The intake and exhaust are both 1.8 ratio. They are torqued to 28 pound-feet. Cold lash is set at 18 thousandths on the intake and 20 thousandths on the exhaust. On the induction side, we needed parts that will complement what we already have, like a good flowing set of cylinder heads and stable valve train. So for the intake manifold, we went with an Edelbrock Super Victor 2. Now this is set to make over 1,000 horsepower on naturally aspirated big cubic inch engines, and it's for a tall deck 10-200 like our 632. The nice thing is, it will take a standard distributor height, no tall deck distributors needed. It's great out of the box performance and will make big power on a big engine. And on top of that, we're going to be running a Holley HP Series Ultra Dominator. This one flows 1,475 CFM with a 2/300 throttle bore. And underneath that, to give us more plenum volume, we'll be installing a 4-hole tapered spacer from Wilson Manifolds. Mahle Motorsports makes it easy to get your bullet together by offering their PowerPak piston kits. Features include Mahle's exclusive slipper skirt design, which reduces drag and weight but increases strength, a phosphate dry film coating throughout, and their patented Grafal coating reduces friction, wear, and noise. Super accurate ring grooves and hard anodized top ring lands and profiled pin bores are machined on equipment designed and built by Mahle themselves to ensure complete control over the quality. The sets also include the correct ring pack and heavy-duty wrist pins, and there are a ton of different applications that are available. And to find what you need, go to MahleMotorsports.com.
Up next, a crank trigger assembly provides incredibly accurate timing for our big block.
Today, we're building a 632 cubic inch Chevy big block for XOR's Willie's Wagon. They requested big horsepower, and this power plant will bring it. And we're talking 4-digit horsepower numbers here. To keep the manifold gaskets in place during installation, we put down a thin bead of Permatex Super Weather Strip adhesive. For an airtight seal between the gasket and the intake manifold, we'll use Permatex The Right Stuff rubber gasket maker. It seals instantly and is resistant to aging, shrinking, and cracking.
It also handles continuous heat up to 450 degrees. A nice thick layer along the China rail gives us a tight seal as well. Once the intake manifold is carefully lowered into place, ARP stainless 12-point bolts will keep it there. Super accurate ignition timing is as important as anything else on an engine like this. So instead of running a conventional style distributor, we're going to be running an MSD crank trigger. It's called a flying magnet. It has magnets every 90 degrees that pass a non-magnetic pickup. It's much more accurate than a conventional distributor. It's more accurate because it has an 8-inch diameter compared to the reluctor inside the distributor, which is roughly 1 3/4 inches. Simply put, the larger diameter yields a finer degree of accuracy. The included bracket can mount on either side of the trigger wheel, depending on what accessories you're going to run. Then the non-magnetic pickup is installed. MSD recommends that the gap between the pickup and the wheel is 50 thousandths. We're using an MSD low-profile crank trigger specific distributor. There are no connections needed aside from the spark plug wires and the coil wire. The crank trigger handles the rest. We're using Felpro steel core gaskets which have a silicone outer layer and compression stops to prevent over-tightening. Next, we needed a rigid valve cover because we plan on pulling some vacuum on the crankcase. So we opted for a set of Summit Racing polished cast aluminum valve covers. We'll cinch them down with more ARP hardware. Moroso billet breathers are built specifically for use with a crankcase evacuation system. Hoses will run from them to the headers in our dyno. Like I like to say, we are dangerously close to getting this engine running on the dyno, and there are a few other parts we have to put on, like the carb, water pump, and such, and you're gonna have to wait till next time for that. Plus, there are some things that we want to try on this engine to help maximize its performance. For more information on anything you've seen on today's show, go over to PowerNationTV.com. Recently, we discussed compression ratio and how it affects performance. Today, we are going to show you how to calculate compression ratio for your own power plant. To determine compression ratio, we must make 5 volume measurements. To keep things organized, we'll record each one on a sheet. We'll start with the cylinder volume at BDC. Since we know that the bore is 4/125 and the stroke is 4 inch, we just plug them into the equation for the volume of the cylinder. 0.7854 times bore squared times the stroke times 16.39. This equation converts the result from cubic inches to cubic centiliters. We do this because our equipment is designed to measure in metric volumes. Our result is 876.15 centiliters. The second measurement is combustion chamber volume. Most manufacturers will list this on their spec sheet, but if there's any doubt, you can measure it yourself. With the valves installed, as well as the correct spark plug, a clear acrylic plate is sealed over the combustion chamber with a little bit of engine assembly lube. With the barrette in place over the hole in the plate, it is precisely filled to 100 cc's. Then it's slowly drained into the chamber until the chamber is full with no air bubbles. And look at that. We'll check the reading on the barrette. Our result is 69 cc's. The third measurement is head gasket volume. The manufacturer will provide the bore and compressed thickness of the gasket, and we'll use those numbers much like we did when measuring the cylinder volume. With a 4/200 bore and 40 thousandths compressed thickness, this yields a gasket volume of 9.08 cc's. The fourth measurement is cylinder volume at TDC. This measurement assumes a perfectly flat piston with no dome or dish. The LS we used has a piston depth of 5 thousandths in the hole, and we'll plug that number into our volume equation. The result is 1.10 cc's. The final measurement is piston top volume. Now, if it had a dome, it would take away volume, or if it had dish or valve reliefs, it would add volume. But since our LS piston was completely flat, we don't need to make this measurement. But if it was not, we would measure it the same way we would measure a combustion chamber. With all 5 volumes known, simply add them together. This is the total volume at BDC and is the numerator in our equation. Next, take the same number and subtract volume 1 from it. The result is the volume at TDC, and it becomes the denominator in our equation. Now, divide these numbers and you have the compression ratio for your engine. Ours is 12.06 to 1. It takes a little time to measure and calculate this value, but it is crucial when planning any engine build.